Good afternoon, friends. The need to excel is a personal drive. It gives me immense pleasure to see so many motivated testers here wanting to learn and improve their skills. Welcome to the STP training webinar, which is the topic for today is Performance Engineering, Ask a Performance Question. Our speaker for the day is James Pulley. I'm Smita Mishra, a professional tester myself, and I'm excited to host you all and James on our STP training webinars. Quick information for all of you. The next upcoming conference we have is Fall 2018 STPCon, which will be held at Arlington, Virginia from October 22nd to 25th this year. The keynotes and workshops have been selected and sessions reviews are almost complete too. So the partial program is up for your review and selection at stpcon.com. Keep looking, more will be added in the coming weeks. Another quick piece of information that I have for you is that there is an upcoming webinar, Fine-Tuning Your Agile SDLC by Melissa Tondi on 13th of June. Melissa is the director at Disrupt Testing and is a well-renowned leader in the world of software engineering. So the link is up for you to review and register. You can go for it. And if you are on Twitter, please share the conference information and about this webinar with your followers and connections. You can also add STP's Twitter handle to your tweets, which is @SoftwareTestPro. You can also note down the speaker's Twitter handle in case you wish to add. And just before we start, few housekeeping points for next 1 hour. All the attendees shall remain muted through the webinar. You can type in your questions and share them with us through your question box. We shall take them up as and when James is done and is asking for it. The webinar shall be recorded and shall be posted on the SoftwareTestPro site for the attendees to go through these later. All right, so let's get started. A very warm welcome, James. We are very thrilled to have you with us today. And let me quickly introduce you for all of us here. James Pulley is the practice manager for performance engineering and test at TEKsystems. For the past 2 decades, James has been helping organizations address issues around software performance engineering across the entire life cycle of applications. James has handled hands-on delivery of performance engineering services as a product trainer, an innovator in the delivery of performance engineering services, and a podcaster on topics related to software performance engineering. All right, James, very warm welcome again, and the floor is all yours now.
Thank you, Smita. Can everyone see my screen?
Yes.
So the topic for today's podcast related to performance, or today's broadcast related to performance engineering, is really one that's near and dear to my heart, which is asking of a performance question. It's an anti-pattern that appears in most projects that go live today. And as we go through the presentation, you'll begin to understand why this is such a dangerous item not to address. First, a little bit of rehash of the introduction. My role, I am the practice manager for performance engineering and test at TEKsystems Global Services. We are a global service provider with facilities in North America and on the Indian continent as well. We serve customers all over the world related to the topics of performance testing and performance engineering. My background, as Smita mentioned, I have more than 2 decades of direct hands-on in the performance engineering discipline, and I am happy to share my experiences in forums such as this and others. So when I was asked to deliver this presentation, the guidelines were really around performance engineering more than performance test. And so I thought it would be worthwhile to discuss how a performance engineer views the universe and to kind of frame up this discussion. And we use for this discussion something that we call the widget. You can think of this as kind of a compass rose that you would see on a map that gives you the directions, north, south, east, and west. Well, this is the north, south, east, and west of how a performance engineer looks at software. We begin with how early a resource is allocated. We look at how large the working sets are. We examine how often the resource is hit, and finally, how long it's held onto before we release it. Because all of those items together impact response time or the cost that we see. So when we think of what a traditional, say, performance tester does in the context of software quality assurance, what we're doing is we're exercising the system in order to gather measurements surrounding all of these items. How long something takes, and through our monitors, when a resource was first allocated, how large it is, how long it's held onto, and how often it is hit. Because if we can shrink how resources are being used in the system, then we can actually improve response times. So if you see someone who's running a performance test and all they're doing is collecting timing records, or they're collecting CPU but none of these other measurements, and they're not asking these questions, then they're probably not really engaged in performance engineering, but they have opportunities for growth in this case. Now, performance engineering is not just isolated in the quality assurance space. These questions related to response time, resources, and how they're being used really are impactful across many disciplines. You can think of business and contracts related to current, say, SaaS application providers. Will the SaaS application provider commit to a response time SLA as well as an uptime SLA? Of course, if we're not educating development on what is required, in many cases, performance will simply be ignored if we have no guidance here. Quality assurance, once again, we have an issue of we need to have this common understanding. Platform engineering, what are we tuned towards? Monitoring, how do we look at production to ensure that we're meeting business requirements and other requirements as well. So the topic that we're going to discuss today really covers 5 of these 7 discipline areas. It's a very large anti-pattern. It covers from business all the way through monitoring. You could make the argument it talks a little bit about capacity planning and simulation, but those 2 disciplines usually take inputs from the others. So if we don't have data that's appropriate, we're not going to be able to engage in those disciplines. So performance engineering, in a broader sense, is really the collection of practices amongst these disciplines. We can ask specific questions related to that compass rose in each discipline, but performance engineering as a discipline is really layered across all of these foundation stones. So what we're going to talk about today, a lot of different development models. We see here the classical waterfall model. It also impacts Agile, and it also impacts DevOps. There is not a single development methodology which is immune from this problem related to asking of a performance question. And really it comes down to the information that's collected at the very beginning. You can, in fact, within your own organization, go and pull a list of user stories or requirements, or as Scott Barber likes to say, desirements. You know, we desire to have these items in the software at the end. And look for any guidance related to performance or security for that matter. I don't want to say performance is isolated in this, but building items for functionality is easy. It's something you see. It's something that's easier to validate. Performance is hard. It requires judgments up front that may actually run counter to some of the functional requirements in order to meet performance requirements. And people on a psychology basis really avoid doing hard things. It's just part of human nature. So if we combine that with functionality is easy, performance is hard, And if I simply don't collect the information, then I'm not going to have an issue, right? Maybe. I would challenge you, once again, go and pull a collection of user stories requirements from your archive in your organization and look for the performance attribute. It's probably not there. So what does this mean for an organization that doesn't collect this performance information right up front in any way, shape, or form? Well, we start with the business. They have a very clear understanding of what they need to do in order to meet business goals. But you know what? Architecture may have a different idea altogether on what constitutes acceptable performance. And you know what? So does platform engineering or ops. And then we get to development, of course. The problem is these are all decoupled understandings of performance. The business knows what it needs, but everyone else is operating on an independent basis and making assumptions related to how performance should be in the enterprise. What we're lacking is this common understanding that brings everyone together to say, okay, this is what we're shooting for. You've probably been in meetings related to performance where you have one side of the organization arguing against the other side of the organization that their understanding of performance was just plain wrong. And this happens quite often in a performance testing context because we lack performance guidance throughout, where we're not even able to ask questions on a single user basis. Are we meeting our performance goals? In this case, what happens is you get all the way to performance testing, and the performance testing goes back and starts asking questions of other parts of the enterprise. Okay, what are the performance requirements? We don't generate them, we don't manage them, we don't own them. We have to get them from someplace. Can you imagine the challenge of performance testing going all the way back to the business and saying, okay, what was this supposed to do? And then we performance test it, as we see here, and all of a sudden we have people in development and architecture and platform engineering telling us we are completely wrong. Our test is totally bogus. It doesn't work that way. Well, you know what? They're probably right, because that performance advisement or guidance has been missing from the entire process up to that point. So we have this decoupled understanding, which impacts not only the business, but it impacts all the interdisciplinary politics, and impacts all the interdisciplinary communication associated with the delivery of performance data and the tuning of performance within the system. But I said, okay, James, you've painted this horrible picture of this chaotic environment going on inside of our organization. Actually, it's probably going on inside of every organization to one degree or another. What can we do? Well, here's where the butterflies and rainbows and unicorns all come into play. And is there something that we can do to address this? And there is actually something that you can do, and it's pretty darn simple. If you are in a meeting and anyone asks a functional question or a security question or a platform question, then that should be followed up immediately with a performance question. Consider your own experience. You're in meetings, you may be in development meetings, and they could go on for hours about what the functional specification of an application is. And it really doesn't matter what your development model is in this case, whether it's Waterfall, Agile, or DevOps. You still have these occasional meetings where you're looking at functions or features or user stories. You're grooming the backlog. But if nobody asks a question about performance or security, we'll throw security in once again, then there is no guidance for the person who is building the code, for the person who is asking the question of a single user, or a person asking a question of multi-user performance, what constitutes acceptable performance. Now, I've been in meetings before where they've gone on for hours and we're about to break, and I say, okay, I want to ask one question before we break, and I'll ask a performance question, and I will receive 5 different responses from 5 different people from as many decoupled organizations: platform engineering, architecture, development, etc. And that exposure, just by asking a question, leads to something that needs to be reconciled, recorded, and carried forward. And I would even make the argument, it's not necessarily what you're asking, it's the fact that you're asking it at all. Because in most cases, these are not asked. And there are many examples of what you can ask. For instance, if we're in a public-facing environment, we want to understand the difference between users or bots on the system, how many users. We need to ensure that our cache model is correct. This is a really good one. How much time allowed for marketing beacons? You can go on some sites today and you'll find 15 different marketing beacons on the site. Why? Because every single group in marketing has their favorite tool. Could you get away with one and maybe collect data off of logs or through that interface for others to consume? You probably can. And especially if someone's loading marketing beacons right up front, because we need to understand as soon as someone clicks on the page that they've clicked on the page, we can't have it at the bottom. Well, in that case, you're putting your content behind another server, which could be slow. So we need to ask these questions. What is appropriate for response? What load are we expecting? Very important for spot sales and things of that nature. Do we have existing data that we can pin this to, that we can take a look at, and we can understand whether we're hitting our load characteristics for what we see in production today? So just keep this in mind. Every time you go to a meeting, ensure that you have a conversation about performance at least once in that meeting, if ever a functional question is asked. Now, this also extends, by the way, to every time you're engaging in a unit test where you're asking if something works. Why not ask how long? Because if it degrades, you would want to understand that. If you're loading up a particular page and you want to make sure that the page renders correctly, why not ask how long? Why not take a look at the developer tools to see how long JavaScript for various functions is working? Why not take a look to see if you have any blocking calls on your page design? Take advantage of the fact that every time you ask a functional question, ask at least one performance question. So TEKsystems last year placed around 16,000 quality assurance professionals at various customers. Most of those are manual or functional automated testers. Can you imagine the power if all 16,000 simply asked one performance question this year? Pretty powerful. I can tell you from a performance engineering and performance testing perspective, most of what we catch in the first couple of weeks are functional issues that have never been asked or interrogated before something gets to performance. And the big one is, if it takes 15 seconds for one user to do it, how are you going to expect it to respond in 4 seconds for multiple users? If it doesn't work for one, it doesn't work for many. So the next steps. Go pull your requirements, go pull your user stories, go look at your backlog, and ensure that you actually have performance attributes associated with your user stories. If they're not in them, make sure that there's a reference. This functional requirement occurs under this other set of conditions, and then point to a dedicated performance user story. So it cannot be ignored, because ignoring this is at your peril. What happens is you will get all the way to production, particularly in a CI/CD model with DevOps, continuous integration, continuous development, and also continuous deployment. If you never ask those performance questions early in the unit testing stage for single users through the single user interface before you get to performance, what you're going to do is you're going to wind up running out of time in the decoupled performance testing phase, and someone will start screaming that we're not going to make our bonus if we don't promote every 3 hours, and it'll get set by the wayside. By the way, finding it earlier is also cheaper, because you're finding it closer to the source. Some scary statistics for you. This gets to asking a performance question. So there's a rule of 72 in finance, which means you can take the number 72, divide it by any number, and you'll get how many periods it takes to double your money. So think about a really small increment of a response time increase, 2%. You take that over 36 builds, you've doubled your response time. Another rule of thumb: if something is not scalable for one user, a business process, a page, a response time to a query, fix it there, and then at the units testing stage, at component assembly, for a single user page, in terms of functional validation. Because if it does not scale for one, there is no sense in taking the cost and the analysis to go forward to ask the question of many users' performance, because you will never be able to hit your target. And you'll find that this is a source of politics, of frustration, project managers getting to the end of a project and it's like, holy cow, this thing doesn't scale, and I have a defined deliverable date. We don't have time to fix it. We're going to production. We do not want that. We want to catch these as early and as often as possible and have plenty of time to fix it. Gartner notes, and Gartner bases their data on many other studies from ANSI, ISO, people of that nature, that it's 1 to 2 orders of magnitude higher to fix an issue if it gets to production, because you've got issues related to downtime that are also very costly. And if you're deployed in the cloud, such as Amazon or Microsoft Cloud Azure, IBM Public Cloud, any high resource cost item is really going to drive your cloud bill significantly higher, and it's going to attack the notion that, hey, we closed our data center and moved to the cloud because it was supposed to be cheaper. All of your savings will simply evaporate as part of that migration if you are not resource efficient. So why do we do this? Effectively, we want to find the issues as close to production as possible, or not as close to production, as close to inception as possible. If we can find a performance defect in a requirement or a user story or your backlog, what you're going to, let's say the performance requirement is all responses under all conditions have to be 1 second or less. Well, if there's not a compelling business or engineering event for that, you might have to build data centers the size of Google and Facebook to actually meet that requirement. That's an example of where we do have a performance attribute, but it's clearly out of scale with the business needs. If we can fix that, and then we can carry that forward where there's a clear understanding of budgets at each tier, then we're going to solve issues on a more cost-effective basis. Today, a substantial amount of code is being promoted to performance testing, which is not performance compliant even for a single user. And this is costly to an organization, time and effort to fix. Some organizations politically cannot refuse to performance test, even if they receive non-compliant code. And we have all been part of those conversations, which are usually highly political in nature, related to, I don't care, but you have to test this, even if it's not working. And finally, we want to address the issues of cost in production. Either that's cost in your own data center, in a hybrid model, or in a full public cloud, where anything which is high resource cost, thinking back to that compass rose at the very, very beginning of CPU, disk, memory, and network, if we can catch those items and we can reduce the working sets, we can narrow the window of which it's allocated, we can reduce the number of times that a resource is hit, and we can recover it as fast as possible, then we will have done our job as a performance engineer to help ensure performance in production. But we can only do that if we have guidance from the very beginning and we have the time and resources required on a human capital basis to ask these performance questions. So this one anti-pattern, if you can conquer it, once again, rule of thumb, whenever you ask a question related to any other part of your architecture, functional, security-wise, always ask a performance question. It may not be in your test. You may simply be functionally validating a screen, but report response time. It could simply be too high, and you would never know. But once it's captured there, it's a whole lot easier to fix earlier in the development life cycle. So I've reached the end of my presentation, which is, in context, this is the number one anti-pattern which impacts performance more than anything else, is this lack of asking of questions related to performance as early as possible and throughout the life cycle. If you have any questions, now is a great opportunity for those. And you can also follow up with any questions to me at jpulley@TEKsystems.com. I don't have my Twitter handle on here, but it is perfpulley, all one word, PERFPULLEY. Feel free to drop me a note there as well. And on that note, I will hand it back to Smita.
Thank you so much, James. It was such an insightful session and pretty eye-opening in terms of what typically people think about performance. So thank you so much. And we do have tons of questions. So we're going to start with them right away.
Okay.
So the first one is, you did talk about it, but I think you can probably explain more in detail. When should we start doing performance testing? As soon as possible, or at the beginning of SDLC, or at the end of SDLC?
I would make the argument that as soon as you ask a single question about the functionality of a piece of code at the unit testing phase, you should be asking how long that code takes to execute. Because if we do have guidance that says, a business process can take a maximum of X, and this piece of unit code is a percentage of X, we have a budget that we can look at and say, if we're exceeding our budget, we need to tune our code for better performance. If we can do that from a developer's perspective, particularly in Agile and DevOps models, we can capture a defect almost at the point at which it's created. I see, for example, a lot of time where I will have a function I'm looking at that's in the unit testing phase, and it has doubled in response time. Now, it may be a small doubling. It may go from 100 milliseconds to 200 milliseconds, but we need to explain why this has occurred. We shouldn't simply just promote it. It's like, okay, well, that's horrible. What caused that? It could be something as simple as 90% of the code wasn't written in build 1, and so we just had a bunch of stubbing out of points there, and now the code is actually almost code complete. And so that's why we're observing the difference. But it could also be something like, well, we changed how much of a resource we were using. Maybe we're on a .NET development model, and our view states grew from 100K to 16 megabytes in size. Well, how about let's go back towards 100K so we can recover our time in this case. That type of asking of questions early and often really serves you well. Today, a lot of performance testing is really decoupled almost at the end of the SDLC, no matter which process you're using, where no performance question is ever asked until you get to the performance team, where it's common inside of organizations that will say, oh, performance, that's their responsibility. And they usually, point to someone over in a corner that look very harried and a lot of empty pizza boxes from late at night and all sorts of things. That we want to avoid. We want to have some ownership of performance. We want to ask those questions about performance all the way throughout.
Thanks, James. So here's the next one. The attendee says, I would like to find out how to deal with management, which doesn't value the non-functional requirement, but makes all the noise after the fact. Even though questions were raised during the SDLC, but questions get overruled by business.
Well, who bears the costs in this case? That's usually the person that you want to have as an ally. An example, let's say we have a bad release that goes out the door. And what happens at that point is the help desk may be totally bombarded. Their costs may go through the roof for supporting that particular application. And they need to have a couple of things. One, they need to have a voice with management if they don't have it already that says, okay, your support costs have increased. Ideally, they should also have a financial path to go back against the project and attach to that project's budget. That's a way of looking at the problem where you get to the symptom and you get to a cost basis. The next question I always like to ask of management is, what is your cost related to poor performance? What can't you do today that you could do if you had better performance? If it's a call center application and call times are running long because of slow response on the CRM system, they might need 20% fewer agents. So think about that in terms of headcount and things of that nature. Would they be willing to accept the trade-off of a little bit longer development cycle and deployment cycle in order to avoid the cost of having to add 20% headcount? Being able to tie that to some sort of financial number, help desk, more headcount in a particular location, a opportunity cost where, say, a sale was lost or had an inability to deliver related to something, or a project running long because of poor software, that's a tangible element. And when you speak to the business, you need to speak to them in their language: dollars, cents, business operations. If you come to them with a technology problem and you're speaking to them in the language of technology, you will probably lose them. You need to speak with them in their language. Smita?
That is a very good suggestion, James. Yes, I do agree that when we're talking to management, we have to speak about what's the value for them instead of, kind of coming up with our set of issues. Of course, we see the issues, but we have to translate that in a language that the management gets. So next question is, James, how do we account for setting up data and environment for performance testing during DevOps sprints, since the process is usually waterfall from estimation to execution?
So setting up data for performance testing, I will say you're going to need to extract data as a separate data set from your test data. And I will say that under no circumstances should you use production data for this. There are many reasons, but the biggest reason for it is once you get production data into a test environment, the access controls, the audit controls are far less stringent, and a lot of this data is walking out the door and being misused in the market today. We want no part of that as an IT professional. If you need to go to test data management solutions and generate separate data sets for both functional and performance, I recommend you do not share data, because your functional group will be changing data that you need for performance and vice versa. This will lengthen your project. Take a look at any of the test data management solutions on the market. Admittedly, I'm not an expert in that space. I do have experts that I go to when I say, hey, I need data. And it's not a trivial task, because ideally you need something that's referentially correct, and you need data which is as clean as dirty as what you have in production, based upon how your data has grown over time. And I leave the actual generation to the experts there. I give them the characteristics that I need for the number of data sets that I'm going to touch. But the big one here is, do not use production data unless you have a 10-page signed contract where you've explained, do not ever use this under any circumstances, and this is my get out of jail card. And if you accuse me of this, you're going to buy me a Ferrari too.
Yeah, thanks, James. But let me just kind of add a little different angle to this question. I'm reading it out again. How do we account for setting up data and environment for performance testing? So I think during DevOps sprints. So maybe besides this aspect of how to generate data, I also wanted to understand, like, when we start a project and we start estimating it, and then we go a typical waterfall model towards execution, and then we have suddenly now going into the DevOps sprints while we are in execution. How do we account for this time where we need time for data generation, for environment setup? I think, like, if you could give us some pointers to the attendee, like what all things they could account for in advance.
What I like to do, rather than continuous generation of data, is tackle that up front as far as data prep, and then have a rollback position on my data storage. Like, for instance, Oracle and Microsoft SQL Server are very good at being able to set a restore point where I can roll back to that point, so I'm not constantly having to generate data as part of what's going on inside of my testing efforts. This is especially important for use once data, or data where you're changing the state of something, and you will need to roll back or generate new data. That is a cost that the project manager actually has to account for that as a task, so it can be budgeted for inside of every effort, or account for it right up front. Does that help to clarify?
Yes, thank you. Another question is, what are the most important metrics that we need to look for, if there are any specific ones you would like to suggest?
So I'm going to hop back to our performance engineering item at the very beginning, so if you'll bear with me. So here we have really how a performance engineer thinks and the minimum data sets that we're looking at collecting during a performance test. By the way, we could also collect this data in production from logs. We could collect it from monitoring tools such as Dynatrace, AppDynamics, New Relic, things of that nature. But the key here is we have a measurement of time and we have measurements of resources. Because if we don't have the measurements of resources, we don't know how to make recommendations to trim them or shape them in order to reduce the cost or time required to deliver on a particular element. So when we're talking about what we should be collecting, this is kind of our minimum set of data. We're looking at CPU, disk, memory, and network. When it starts, how large, how long, and how often. Each one of these can decompose into a number of other statistics. For instance, under CPU, we might have application and system CPU. We might have context switches. We might have other items related to CPU. Under disk, we might have index utilization if we're looking at a database. We might have raw throughput bytes. We might have disk errors. Under network, utilization, errors, things of that nature. Memory, we might have file descriptors or file handles. So you can decompose to find out what specific component is maybe under stress, but as a minimum working set for the things that you need to collect for analysis purposes, this is where we're at. Response time, the finite resource pool, CPU, disk, memory, and network, and then how those resources are being used.
And the quick question is, do we have to build a framework to perform the performance testing like we do in cases of UI automation testing?
No.
That's a quick answer. Okay.
I get told I need to build a framework quite often by people who don't understand performance testing, because they've received that answer from people who also don't understand performance testing, and they're using tools that are not designed for performance testing to do performance testing. And because they use the term framework all the way around, I've been told I have to have a framework, and I've said, okay, please define a framework for performance testing. And usually it cannot be defined because we are going, in performance testing, typically we are going after the protocol level conversation between the client and the server, which could change from release to release. And it is very difficult to build a defined framework that is going to change dynamically as the application changes.
All right. Okay. Can we pick the next question, James?
Sure.
Yeah. There's one more that says, according to the knowledge accumulated, at your end, what are the best practices, if any, when doing performance testing?
There are many. There are a number of common patterns that we see that negatively impact performance testing. This asking of a performance question early and often is one, but a couple of other items that I look for explicitly in any type of performance testing solution is ensure that you are checking for expected results. I know this seems like common sense in a quality assurance discussion. For every step, there's an expected result, but there are a substantial number of test artifacts on the market that never check for an expected result. And HTTP 200, in the case of a web environment, is assumed to be correct, but the content may not be correct. And the example that you will see is 1 or 2 pages downstream, you'll receive some sort of HTTP 500 message because the business process has come off the tracks and you're making a call which is out of context with the state of the system at that point. So always ensure that you're checking for expected results. Next up, and this goes back to scientific method, ensure that your tests are reproducible. There are also a number of tests on the market that, hey, you can't run them twice and achieve the same result. Well, if I can't run my test twice and achieve the same result, what does that mean for its ability to predict performance in production? It would show that there's a really small likelihood that that performance is going to be consistent in production as well. And if your test is non-reproducible, then take a look at why that is the case. Either changing environments, changing initial conditions of the test, but go back to your solid testing foundations. Go back to the solid scientific method, and put a really critical eye on your tests. Are you documenting them well enough that someone else could pick it up and run it and achieve the substantially similar result? Next up, make sure that you're varying your data as a real user would. You don't have fixed data inside of your scripts, and it's fairly dynamic in nature. And of course, one of the largest anti-patterns that we see in the market today is people running tests and only collecting response times. No monitor data, no integrated monitors. And this takes an architectural eye to figure out what you need to monitor on each system and how you need to monitor it. But if you're not monitoring in a performance testing context, you're not collecting enough data to actually perform any sort of analysis. The actual value in a performance test is not the test itself. This may seem counterintuitive. The value of the performance test is the collection of all the data that allows you to perform analysis, and it's the analysis which is adding value in this performance testing context. So if you don't have enough information to analyze, then you won't have enough information to actually deliver value, and that will actually put your job at risk downstream, because your stakeholders will be like, well, I don't understand the value that I'm receiving from performance test, and in that case, they're only going to be willing to pay a very small amount of X for the small amount of value that they're realizing for that service.
Thank you, James. As we are heading towards the last 10 minutes, there are more and more interesting questions which are coming in. So here is the next one. Okay. How does one deal with the cloud SaaS administrators who say that resources are infinite in cloud SaaS model?
Well, that's an interesting question, because just yesterday or day before, I thought I saw that there was a performance problem with Office 365. And you will hear often that there are performance issues with these SaaS applications. Ultimately, on a box, you are finite. It is only a question of how many resources you use versus how many resources the other tenants are using. Salesforce, as an example, will tell you that if you get too busy, too hard, too fast, they will throttle you, slow you down in order that you do not impact other customers. So this would imply that there is a finite limit to resources that you can exceed, and you will have performance problems. Amazon itself will tell you that they are not responsible for your performance. You are responsible for your performance. Now, there are design models that you can use where you scale horizontally. For instance, you can use loose coupling between architecture components, and you can spin up multiple consumers and producers that feed queues, and you can scale horizontally, and then as load decreases, you can have these nodes shut themselves off. So there are design models that can account for this within the available resource models of the cloud and the ability to spin up and shut down very, very rapidly. But anyone who tells you that resources are infinite really needs to be challenged on a pure physics basis. Even if you grabbed an Amazon data center, resources are finite within that one data center. If you grabbed all data centers for Amazon, they're still finite. Now, they may be significantly large, but there is still a limit. And in a multi-tenant environment where you are sharing hardware with someone else, how you use resources, it becomes very critical because you want to be a good tenant and you want to maintain your performance without impacting others. Just imagine what would happen if the other tenants were all of a sudden using a whole lot more resources from your pool and you had to suffer.
Mm-hmm. But don't they have the elastic models, James, where they say that, pay as you use and just, of course, these resources are still finite, but for a particular application, they could appear as infinite.
Sure, you could scale vertically, but even within that scaling, there is a limit on the particular host until you jump to
Mm-hmm.
another host or add a third host or four hosts. There's still a limit, and you're going to impact others in that case. Something as well that the resources which are driving that limit, that is, you need more CPU, you need more disk, you need more memory, more
Mm-hmm.
network, that's very costly. When you hit that auto scale and you start allocating new resources, your bill goes up.
Yep, multiple
You know,
folds. Yes.
that's not free. So if you have a developer who is costing you on that, there's every possibility that a developer who is poorly resource efficient in their code could cost more on their web bill than their entire compensation over the course of a year.
Totally. We have to be careful on the use of it. Uh, yep. All right. So, moving on to our next question. And folks, if you have more questions, keep sending them in. If we don't cover them in this session, we will get back to you uh, through a blog site. So, don't worry about your responses, you will get them. All right. Here is the last question that I'm going to pick for now.
Okay.
That is, from your own personal experience, how do you go about performance testing for a new web application where there are no SLAs, service level agreements, and when asked business, uh, they simply say, I don't know, you are the expert? Such a valid question.
Okay, from a quality assurance perspective, I cannot both own the requirement and assess the requirement. So we have a process issue here. Somebody has a business context for why this new application was built. What problem is it trying to solve? And what problem is it trying to solve on a cost efficient basis? That is the person that we need to find. Now, I use kind of a rule of thumb on who is that person. I ask who is going to get the bonus if this is successful from a business perspective. That person you want to make your ally. They know exactly what the system has to do and exactly how it has to perform because their bonus is on the line tied to it. And they will be able to tell you in very precise terms what it needs to do. So if you get pushback on that, ask who gets the bonus if it's successful. Go to that person, buy them beer, pizza, lunch, whatever it takes, get to be their friend, they will tell you.
Mhm. Yes, and just to add on top of it, I quite a few times encourage people to look at competing applications and other applications in the same business domain. If possible, if you do have access or you can get access to the marketing research done before the application got into development, or if there is any kind of access to the users, we could get some insights. Just a few things to add to what James said.
Thank you, Smita.
Oh, yeah. All right. So that brings us to concludes the webinar for us today. Okay.
Thank you, everyone, for your time today. If there are additional questions, please feel free to take advantage of my email address, jpulley TEKsystems.com, and I'll be happy to address them.
Thank you so much, James. It was such an insightful session on performance and where all we could start with it in our daily work as testers. And thank you, everyone, for joining in, and more importantly, for being so engaging and making the most of the webinar for yourself and for the whole group. If you want to see more such sessions and learn more about performance, come over to STPCon Fall 2018. James is also going to be there.
It's a great show. Everybody should go.
All right. Stay tuned for more webinars and online trainings coming soon at SoftwareTestPro.com. And if you haven't signed up yet for the upcoming webinar, which is Fine-Tuning Your Agile SDLC by Melissa Tondi on 13th of June, then the link is up for registration. Please go ahead. And again, thank you, everyone. Have a great week ahead. See you all in Virginia in October 2018. And have a great year ahead, all of you. Happy learning.